Welcome to Statistics. This is Unit 2, Lesson 4. This is talking about the empirical rule, or also known as the 68-95-997 rule, and assessing normality. The lesson is called, Do You Have 5 Seconds? All right, turn to the lesson, please. So what I had everybody do was the first part, and that to label the 1, 2, and 3 standard deviations away from the mean when it gave me this information, that the mean was 5.02 seconds and the standard deviation was 0.1. So the way I did that was, the first of all is, since the mean was 5.02, that's in the middle, and then I added 0.1 to get all of these other values. So 5.02 plus 0.1 is 5.12, etc. And then I subtracted it to get the rest of them. So then I'm going to go ahead and do the math here. It says, what is the value of one standard deviation below the mean? Well, that's just identifying where one standard deviation below the mean is. This is the mean, and each one of these is a standard deviation. So one standard deviation below the mean is equal to 4.92. What is the value for one standard deviation above? So that is going to be 5.12. All right, so for the next one, then it asked me just to guess what the percent is of this green area. So that's really what it's asking me for the green area here, to give me what is the percent of this. And that was my guess. Okay, then it asked for 2 standard deviations, and then it asked for 3 standard deviations. So for 2, I simply did the same thing. 1, 2. That didn't look as pretty. Okay, let me just make it look nicer. Okay, so 1, 2, let's get that out of there, and let me just change the color just so we can see exactly what we're doing. So we went 1 standard deviation, 2 standard deviations. So it's 4.82, and then 1 standard deviation, 2 standard deviations away from the mean. And so that's where the value got. And then again, this was just a guess, and just kind of gave me a guess. And the last one was 3 standard deviations. So 1, 2, 3 standard deviations, and then 1. That did not turn out what I wanted. There we go. Excellent. So 1, 2, 3 standard deviations. Excellent. Okay, and so then, again, just an estimate of where my data is. So it gives you an applet you can use so you can actually find the percent, but you can also see, and that just kind of shows you how to do it but I'm going to give you the actual rule that we have been doing. And the actual percent between 1 standard deviation, 2 standard deviations, and 3 standard deviations, this gives you the accurate percentage. However, we use a kind of a truncated rule that's pretty close, which is called the 68, 95, and 99.7 rule. So that means that the green area represents 68% of my data will lie within 1 standard deviation of the mean. It's going to lie there in the green area. 95%, this means that 95% of my data is going to be within 2 standard deviations of the mean. So all of this. So basically, if I counted up all my data, I'm going to see that 95% of it is between the values of 4.82 and 5.22. And then finally, 99.7%, that's going to be from here. It's 3 standard deviations, so it's basically almost the entire curve. And so 99.7 means almost the entire data set, if it's a normal distribution, is going to lie between 4.72 and 5.32. All right? So then it says, what percent of the stopwatch times are less than 4.82 seconds? So if I go to 4.82 seconds, I say, okay, 4.82 is located right here. That is 1, 2 standard deviations below the mean. Well, according to my 68, 95, 99.7 rule, from here to here, that's 95% of my data. But if that's 95%, I'm left with 5 more percent, because the entire area of the data is going to be 100% clearly. So that means this part and this part are left out. So 5% divided by 2 is equal to 2.5%. So that's 2.5% on the right and 2.5% on the left. And so that's why my answer is going to be 2.5%. Okay, it says what proportion of the stopwatch times are between 4.92 and 5.22, which now you can see the shaded area. So the shaded area is this green area that I'm looking for, plus the blue area that I'm looking for. But the green area has already been told to me that that is going to be one standard deviation of the mean. So that's going to already been told to me that that's 68% of my data. So that's why the 68 comes from right here. Then the 13.5, I'm going to show you where that comes from. Well, if this is 68% of my data, then the rest of it, again, similarly speaking to like we did on the last one, I'm going to have 32% left over, which 32 divided by 2 is 16, right? So that's 16%. But I don't want all the way out. I want it to stop here. So since that's 16%, I got to find out what that is. And remember, we just found out what that was, right? We just said, oh, well, we just did that one in the last one. That was 2.5% right there. So this little part is just 16, minus 2.5, which is 13.5%. And that's where that blue area comes from. Because I just took the 16% that we found out because it was the outside of the 68, and then remember the 2.5% is on the outside of the 95. All right, the next one asked me what stopwatch this time is the 84th percentile. So what I want to do is basically find where 84% comes into play. So I'm just going to kind of say, well, we kind of already know some of the stuff, so we're just going to kind of tack it up. So you already found out that we know from here to here is 2.5%. We even know here to here is 16%, right? 2.5%, we know that's 16%. But obviously we know this part here, that's even easier, that's half of the data. So that's 50%. And I need to keep going until I get to 84%. Well, I know that the middle here is 68%, so that means each side is 34. Well, if starting here is 50%, then I add 34 more, that's going to get me to 84, and my value is going to be right here. So 5.12 shows me that it's above 84% of the data. All right, this is what I wanted you to learn today is, first of all, the empirical rule, which is the 68, 95, 99, 7 rule, says this, that one standard deviation of the data is 68% of my data is within one standard deviation. 95% of my data is within two standard deviations, and 99.7% of my data is within 3 standard deviations of the mean if it's a normal model. This little thing means normal. The first number that's going to be here is my mean, and the second number is going to be my standard deviation. And these are just symbols that mean mean and standard deviation. And the labels are down here where this is my mean, and I go up 1 standard deviation, 2 standard deviations, 3, and then subtract 1, 2, and 3 standard deviations from the mean on the left side. 3 standard deviations almost contain the entire normal model. Okay, the next learning target that I want you to see is assessing normality. In order to assess normality, that you're going to see what the shape is, and if the shape is unimodal, that means one mode, one peak, and symmetric, then you're going to see, first of all, this could be normal. Then you're going to see if it fits this empirical rule, which is the 68, 95, 997 rule. You're going to see if your data lies within 1, 2, and 3 standard deviations of the mean, and we're going to be doing that in the next couple days. Okay, let's check for understanding. So what you were supposed to do here, yours gave you data, and you were supposed to put data in. You can change your bins where your bins can look like mine. I have the bin size is equal to 1, and you can change that. And then I have the minimum, as you can see, is started with 12. And so yours would look exactly like mine if you wanted to. Make sure you remember to do a title. So this one doesn't have a title. We should put a title on it. It asked me that this is measurements, how big is the fridge? So I would put fridge size. It could be named anything. I need to make sure I have a label. Another label, this is the frequency. I need tick marks, which are these. I need tick marks, which is these. And then that's going to be completely, and then an accurate graph. All right, so this one is asking, can you calculate my data values within 1, 2, and 3 standard deviations of the mean? So this is literally what I did. It gives me my mean right here, 15.825. it gives me my standard deviation, which is 1.217. So that's where these are coming from. And if you notice, I'm multiplying by 1, 2, and 3 standard deviations of the mean. So what I'm doing then is, this doesn't have it, but yours had a list of data. And that's how we got the histogram. But I am counting to see how many pieces of data are between 4.608 and 17.042. So it's going to be, if they equal 17.402, that's contained. So when I counted, I found that 24 out of 36, because I have 36 pieces of data, were contained in that within one. This is called one standard deviation of the mean. And I get 66.7%. I do the same thing for 2 and 3 standard deviations, and this is the results I get. And because it's really close to my 68, 95, and 99.7%, and it's unimodal and pretty symmetric. Symmetric just means, hey, I throw a blanket over it and it looks about right. Because it's unimodal and fairly symmetric, we can say that yes, this is indeed normal, and because of it fits this rule. And that's what I did for 3. Okay, for this next one, it says justify my answer to see if my usable capacity between 13.6 and 19.6. So if you do between 13.6 and 19.6, you can see this is already a normal model. 1, 2, 3, 1, 2, well, not quite, but almost already a normal model. And you can see your area. It's like, okay, well, that's going to be 95% because that's 2 standard deviations, and 0.0235 because that's that other little piece that's between 2. It's this here. It's 1, 2, 1, 2, and it's this little piece here that's between 2 and 3 standard deviations, that little piece. And so that's going to be, if you look at that, it's like, okay, that's going to be between 13.6 and 19.6 because that's 97%. So what you're trying to do is find the value that is between this area. And so that's exactly what it did. It says, okay, this is 97.35%, and you're going to find the area. Find and interpret the 16th percentile. So the 16th percentile is 14.8. And that's because it's approximating about 16% have a usable capacity of 14.8 or less. And you can see that it's saying, okay, let's go ahead and put because it has the mean of 16 and the standard deviation of 1.2. And so if you drew your normal model out of 16, and then this is going to be 14.8, and this is going to be 13.6, and this is going to be 12.4. For the 16th percentile, well, you know that 16%, remember, we know that 68's in this here, and 16's out here, and 16's out here. Because 16 plus 16 plus 68 is 100. And so that's how we got the value of 14.8. All right, thanks for listening, and I'll see you next time.